normal distribution. A random variable means that the designated variable, we usually use x, can take on any designated number. A probability density function, PDF, is an equation used to compute probabilities of a continuous random variable. Continuous means decimals and fractions are possible. The normal distribution is a bell-shaped curve. Most of the values are found close to the mean. The height of the curve represents the frequencies, how many. The mean, average, is found in the middle. It is symmetric, same on both sides. If a teacher grades on a curve, that means the grades close to the class average get a C. You must be higher than average for a B. You must be extremely higher than average to get an A. Each student's grade is based on how the student did on the test in comparison to the average. Is this good or bad? It depends on whether the person's grade is better than the average grade. If a distribution follows the empirical rule, then the distribution is called a normal distribution. The empirical rule states the values of the mean plus or minus the standard deviation will have a certain percent of the whole. Values that lie within one standard deviation of the mean will account for 68%, and that is the navy blue section in the graph. Values that lie within two standard deviations of the mean will account for 95%. So in the graph, that would be the navy blue section plus the orange sections add up to 95% of the whole curve. Values that lie within three standard deviations of the mean will account for 99.7%. So if you add up the baby blue sections plus the orange sections plus the navy blue sections, this will account for 99.7%. The whole is 100%, so the little bit that's left off on the tails, the ends, that accounts for the whole thing. Example, the birth weights of full-term babies are normally distributed with a mean of 3,300 grams and a standard deviation of 500 grams. If you take the mean plus or minus one standard deviation, that will equal 68% of the values. So we're going to take the mean and add and subtract 500. The mean is 3,300, the standard deviation is 500. So take 3,300 minus 500, 3,300 plus 500. 68% of the babies are between 2,800 to 3,800 grams. Using the same numbers, the mean plus or minus two standard deviations gives us 95%. So we're going to take the mean, 3,300, and add or subtract 2 times the standard deviation of 500. 2 times 500 is 1,000. So 3,300 minus 1,000, and also 3,300 plus 1,000. So 95% of babies are between 2,300 to 4,300 grams. Using the same numbers, 3 standard deviations will equal 99.7%. 3 standard deviations means 3 times the standard deviation of 500. 3 times 500 is 1,500. So 3,300 minus 1,500, 3,300 plus 1,500. 99% between 1,800 to 4,800. Draw the curve using the numbers in the previous slides. So we see 3,300 is the mean, it's in the middle. To get the next values, you subtract 500 going to the left, go back to the middle, 3,300, add 500 to go to the right. Okay, we're adding and subtracting 500 because that is the standard deviation. For example, in the middle, 3,300 plus 500 is 3,800. You keep adding and subtracting going left or right. Subtract to go left, add to go right. What if it asked you to shade the area to the right of 4,800? Okay, first you would go back to see this slide on the right and see where 4,800 is. We have 3,300, then 38, then 43, 4,800. To the right would shade the area to the right. Areas represent probabilities. The entire curve equals 1. Suppose the area under a normal curve to the right of 4,300 is 0.0228. Since it's said to the right, that means that the probability is 0.0228 that the birth weight of a randomly chosen full-term baby is more than 4,300 grams. Okay, let's go back to right here. Okay, the average is 3,300, and if we're at 4,300 and we're shading the area to the right, that means babies that weigh more than 4,300 grams. Okay, so if it says the area to the right is 0.0228, that means that's the probability that babies weigh more than that. That's the end.